All right, so let's simplify the fifth root of negative 96, x to the negative 10th, y to the 13th. So negatives are confusing, so I like to just take care of them right away so I don't have to worry about them. So first, like the fifth root of negative 96 is like the fifth root of negative 1 times the fifth root of 96. So any odd root of a negative, you're just going to turn the whole expression negative because negative 1 times itself 5 times is negative 1, which means the fifth root of negative 1 is negative 1. So we can bring that negative outside the radical. All right, and now we have negative the fifth root of 96 times x to the negative 10th times y to the 13th. Now, this x to the negative 10th, I'm going to get rid of that negative as well by bringing it down to the denominator. All right, and this should all be under the same radical. All right, times y to the 13th. All right, so you can multiply or divide radicals in any order. So now I could treat it like this. So negative times the fifth root of 96 times y to the 13th over the fifth root of x to the 10th. All right. Now, the fifth root of 96, that's the same thing as 96 to the 1/5 power. So I have to look for perfect fifths that go into 96. So I'm going to factor it. So 96 is divisible by 3. It's 32 times 3. And then 32 is 2 to the 5th. So that means the fifth root of 96 is going to be 2 times the fifth root of 3. So now that 2 is going to come outside the radical, and then the fifth root of 3 stays inside the radical. Now the fifth root of 13, of y to the 13th, right? So see how I'm breaking this complicated problem into a bunch of smaller, simpler problems, right? So 13 is y times itself 13 times. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3. All right. So I'm looking for groups of 5 y's. So there's 2 groups of 5 y's. So y to the squared comes outside, and there's 3 remaining. Now I don't suggest doing it this way for variables because there's a simpler way. When you're taking a root of a variable to a power, you could divide the power by the index. And since 5 goes into 13 twice with a remainder of 3, that means you have 2 groups of 5 factors that come outside the radical, but a remainder of 3 means there's 3 more factors of y that stay inside the radical. And then with the same logic, the fifth root of x to the 10th is just x squared. And now we don't have any radicals in our denominator. This is completely simplified. We have no negative exponents. So this is that's the final answer.